As the point approaches the maximum, you see the slope is positive, then it goes to 0, and then it becomes negative. So at a local maximum, the rate of change of slope is negative. As the point approaches a local minimum, we see it changing from a negative slope to a slope of 0, and then it becomes a positive slope. Therefore, at a local minimum, the rate of change of the slope is said to be positive. This section of the curve is decreasing, and the slope at any point on this section will always be negative. You can see this from the diagram. So we now have a formula. dy dx is less than 0 for decreasing function. In the same way, on this increasing section of curve, the slope is always positive. So we now have dy dx is greater than 0 for increasing functions. We're about to approach a point of inflection. As we approach this point of inflection, you will notice that the slope going in is positive, then it becomes 0, and then as it leaves the point of inflection, it's positive again. Because the slope approaching this point of inflection and leaving this point of inflection has the same sign, in this case they are both positive, we can say that the rate of change of the slope is 0. At this point of inflection, the slope is equal to 0. This is only true for this point of inflection and is certainly not true in general. At the end of this section, we'll be looking at all the key points: local maximum, local minimum, point of inflection, increasing and decreasing sections, and the formulas associated with them. None of the formulas in the last 4 sections are given in the exam. It is absolutely essential that you learn them. If you learn them and quote them, you will get marks. Please copy out all these notes.